The topic of today's step question is numerical reasoning and divisibility. I like this question because, although it's from step 2, it doesn't require very much at all in the way of background theory and knowledge. So the question starts by saying that show that if n is an integer, satisfying this equation here, n take 3 cubed plus n cubed equals n plus 3 cubed, that n is even and n squared is a factor of 54. We're then going to deduce that there is no integer that actually satisfies this equation. Now, normally I write down, if it says n is an integer, I tend to write that down, and the reason I do that is just to make it clear to me what the conditions are. N could, of course, be negative here. So, we've got our equation. I'm going to multiply out the brackets and simplify. And it seems to me that taking n plus 3 cubed, take n minus 3 cubed to the right will give us a nice simplification, because when we expand our brackets, there are going to be terms that cancel. So using the binomial expansion, or multiplying out 3 brackets, we get n cubed add 3 times 3n squared, add 3n times 3 squared, add 3 cubed, take n cubed minus 3n squared times 3, add 3n times 3 squared, take 3 cubed. And the odd terms cancel, leaving us with 18n squared, add 54, or, if it's more useful, 18 times n squared plus 3. Now the first thing we need to explain is why n must be even. The right hand side is even because of the 18, therefore n cubed is even, and we know that if n cubed is even, n must be even too. That's a well-known result that we can quote here. So n is even. We can see the 54 mentioned in the question looming large, so I'm going to take the 18n squared to the left, n cubed take 18n squared equals 54, and a simple factorization is that n squared times n minus 18 equals 54. From that, using divisibility, we're dealing with whole numbers, n squared must be a factor of 54. We could also say, the question doesn't ask this, that n minus 18 is also a factor of 54. And we could also say that n minus 18 must be positive, because n squared times a negative number will not equal 54. Anyhow, n squared is a factor of 54, so it must be 1 or 9, so n is plus or minus 1 or plus or minus 3 as the only possibilities. But we showed earlier that n must be even. 1 and 3 are not even, therefore there is no integer n satisfying the relationship that has been called star in the question. So here we have assumed that n satisfies this equation, and we have effectively reached a contradiction, so there is no integer n satisfying the equation star. Now, often in step questions, they lead you through a first part, then give you a second part in which you are expected to have learnt from the first part. And this question is a bit like that. So, show that if n is an integer and that n take 6 cubed add n cubed equals n plus 6 cubed, again n is even, and we need to deduce, once again, there is no integer n satisfying the equation double star. So, starting in the same way as before, we have n take 6 cubed plus n cubed equals n plus 6 cubed. Rearrange that, n cubed equals n plus 6 cubed, take n minus 6 cubed, and just as before, that expands and cancels, giving us 2 times 3n squared times 6, add 6 cubed. which is also 36 times n squared plus 12. Now the right hand side is evidently even, the 2 at the front makes that clear. N cubed is even, therefore n is even. What else can we say? Just as before, let's take the 36n squared to the left. So we have n cubed take 36, n squared equals 12 times 36. Factorising n squared, n take 36 equals 12 36s. I haven't worked out 12 36s. It's not hard, but I may not need it. So n squared must be a factor of 12 36s. Now this time there are several squared numbers satisfying these conditions, and some of them are even numbers. So we discount 1 and 9 because they are odd, but we are still left with 4, 16, 36 and 144. If you're listing possibilities, make sure you've got all of them. So n is plus or minus 2, plus or minus 4, plus or minus 6, and plus or minus 12. Why are none of these possible? Well, going back to our expression, we have n squared, n take 36, equals a positive number, which means n must be bigger than 36, and none of these possibilities are. So in each case, n take 36 is negative, so can't satisfy the equation, so there's no integer satisfying the equation double star. So quite a nice question, using very little apart from the binomial expansion for n plus 3 cubed, etc., and a bit of divisibility and some systematic listing. I imagine most candidates found that a nice starting question, a good question to start with, and one that illustrates fairly nicely how we use numerical reasoning.